All right, hello once again, Jeff Scott of Rankin Technical College, and as part of the Rankin Technical College online AWD Application and Web Development 1100 C# programming class for the spring 2024 semester, I've been doing a series of video presentations based mainly on the PowerPoint slides for our textbook for the class, that being Muroc C# 8th edition. I've also spent the first, about 11 chapters going through a payroll application that I changed in most chapters. Then in the next section that we went over, we did an object-oriented example where we kind of took this payroll program and transitioned it over to an employee application. All right. Now I just finished 19. I'm doing these out of order so I can go over 18 now. So chapter 18 is on how to use LINQ. I believe LINQ stands for, and we'll probably see it in here, I think it's line integrated query or something like that. All right. But it allows you to perform database types of operations on either databases or non-databases. The stuff we looked at in chapter 19 only worked with databases. LINQ can be used with non-database values as well. So notice we've got one applied objective and several 10 knowledge objectives. So our applied, use any of the LINQ features presented in this chapter to query things like arrays, sorted lists, or generic lists. Our knowledge, in general terms, explain how LINQ is implemented. Name the interface that a data source must implement to use LINQ. Describe the three stages of a query operation. Describe how the type of a query variable is determined. Describe how deferred execution works. Describe when a query operation results in a projection. Describe when a query operation results in an anonymous type. Describe the purpose of the following: from, where, order by, select, and join. Explain how extension methods and lambda expressions are used with LINQ. Compare method-based queries to query expressions. So that's what we've got to look forward to. Now, I'm going to put something in here, but I'm going to put it a little bit down further. If I'm working with a database, so let's say that I'm working with a database, and I want every person who lives in Missouri, okay? And let's say that I've got a table, so I've got a table called customers, and I want every bit of customer information. In fact, let's say that I just want the first name and the last name of all customers who live in Missouri. I would say something like this: select first name, last name from customers where state equals Missouri, like that. All right, it would be something like that. That's how we do it in SQL. So again, this is how we would do that in SQL. If we wanted to do the same thing in LINQ, we have to use this type of syntax. Now, we won't use in here, we won't use the word join in this example, but we're going to write something. Oops. So let me move this over. So we would say from customers where state equals Missouri. Now we don't have an order by. Let's put an order by in here. We'll say order by last name. All right. So here, order by is one word. Now I can meet these lowercase, uppercase, or mix them, but I'm putting the keywords in uppercase. But here, order by is one word. So order by last name. Finally, select first name, last name. Make this a little bit wider there. So I can put that in there. Whoops, still didn't take it. So look at the two queries. This one is written using LINQ. Here, all this, and this is written using SQL. They're both giving back the same type of information. The difference is, again, where we're saying here from customers, this could be an array, a sorted list, or something else. This must be a database table. All right? So why do you want to use LINQ? This is what they're mentioning in here, okay? Makes it easier for you to query a data source because the language is basically integrates well right with C#. Next, makes it easier to develop applications because it'll bring in the IntelliSense. In addition, it'll do compile time syntax checking. So if you write something wrong, it'll let you know right away. And there's built-in debug support. Next, it makes it easier for you to query different types of data sources. All right. Finally, it makes it easier for you to use objects to work with relational data sources. This is all stuff we're going to go through. Now, when you are working with LINQ, as it says here, there are 3 stages of the query operation. Number 1, you get the data source. Again, could be a database, could be a database table, could be an array, could be some kind of a list, and there's other things it could be as well. Second, you define your query. Third, you execute the query and you return your results. So, what do we have here? All right. Well, if you notice, we have an array. This is an integer array called numbers, and numbers 0 is equal to 0, numbers 1 is equal to 1, numbers 2 is equal to 2, numbers 3 is equal to 3, and numbers 4 is equal to 4. So that is going to be, in this case, that's going to be our data source. Then we define our query. Again, from where order by select. From where order by select. So from number in numbers. What is number? It's kind of like when you use a for each loop, we're just defining a new variable called number that's going to iterate through the numbers array. All right. And the where says if the number is evenly divisible by 2, all right, we want to select that number. And we want a listing of all these numbers that are even, and we want them in descending order. So when we run this, we should get 4, 2, 0. We leave off 1 and 3 because they're not even numbers. Then there's the code below the query that executes the query. All right. And again, there's what we get. You're going to be working with this and looking at this and seeing this along with database stuff as well. And we're going to really go into it in earnest in a little bit here. All right. All right. An example that uses an array of decimals as the data source. So we've got a decimal array called sales totals. Sales totals sales totals sub 0 or element 0 is 1286.45 M. Sales totals sub 2 or element 2 is 2433.49 M. Sales totals sub 3 or element 3, 1, this is element 0, this is element 1, this is element 2. 2893.85 M, this is element 3, 2094.53 M. Then we define our query expression. Now notice on here, we've got a from and a select. From and a select. We want all of them, so there's no where. We're not doing any ordering, so there's no order by. And what is this doing? This is saying, I want you to go through all of the sales that are in here and add them to a variable called sales. So this line that you see right here, sum is going to hold 1286.45 M plus 2433.49 M plus 2893.85 M plus 2094.53 M. All right. So what they're going to do now in this chapter is they're going to go through an example of this. All right. So as it says, this is an example that uses a generic list of invoices as the data source. So what do you have here? You're saying that each invoice consists of this stuff here. An integer for the invoice ID, an integer for the customer ID, a date time for the invoice date, a decimal for the product total, a decimal for the sales tax, a decimal for the shipping, and a decimal for the invoice total. And if we look back far enough, I'm sorry, not on this one. Let me go back to where we were. But if I look at the one we just went over, and that was in 19. That was this. All right. Invoice ID, customer ID, invoice date, product total. Same for sales tax, shipping, and invoice total. All right. So what we're doing here is we're basically in here setting up a database table. What we're doing in here is we're setting up a class, and we're going to create a list of these invoices. And that's what we're going to be able to manipulate utilizing link. Again, this is going to add up all of the invoice totals in here. We can put a where in there. So notice there we want a where, but it's where sales are greater than 2,000. So if we look in here, that's going to eliminate just this one because the sales there are not greater than 2,000. It's going to keep this one, it's going to keep this one, and it's going to keep this one. Next, then we've got the code that executes the query. That's it. So again, it'll show the three that were more than $2,000. So what we're doing in here is we're just looking through a boatload of examples. All right. Next, we've got a from, a where, and a select. So we want to go through our list of invoices, and where the invoice total is greater than 150, we want to select it. If it's 150 or less, we skip it. And then we've got the corresponding code that executes the query down here. And this is what we get. Here's one that sorts the sales total array. You'll notice it uses the order by. Order by when you work with SQL is 2 words. Order by when you work with link is 1 word. All right. And with both of them, if you don't say ascending or descending after it, it's ascending. So you can see those are in ascending order. So there's a bunch of examples in here. I'd be a fool to assume, yeah, I'm going over this with you. I'm doing a good enough job that you should all get it. You're going to have to play with this stuff and look at it for it to really make sense. But part of the, if you look at it, that I want to be a complete C# programmer, then part of getting on that journey is to be able to understand and use link. Okay, so here we've got everything. All right, from our invoice list, we want to select the invoices where the total is greater than 150, and we want to order them by customer ID. That's my most major field, and if there's any with the same customer ID, then I want you to give me the invoice total in descending order. And there's, you see it. So 2020, so 259 is more than 191. Okay. All right. Another example. As it says, this selects key values from a sorted list. All right, so what do we have in here? We've got names and we've got sales totals. So the employee name is Anderson. The sales total is $1286.45, etc. Okay, so from this sales, we want to select the sales key, and that's the person's name. It's the key first, and then the value. Key value, key value, key value. So we want the name of everybody who had sales greater than 2,000. And we want to order it by, so the one with the greatest sales should go first. We're doing it by sales value. So it should be Thompson, Menendez, and Wilkinson. We're skipping Anderson because Anderson's sales were not greater than 2,000. So Thompson, Menendez, and Wilkinson. And you can see that's exactly what we get here. All right. Okay, here's a query expression that creates an anonymous type from the list of invoices. So what do we have here? We're going through the invoice list. We are finding every invoice total that's greater than 150. We are ordering them by customer ID, and if there's any matches, then by invoice ID in descending order. From there, we're basically doing the equivalent of creating a new result set that should have just customers and invoice totals. All right. Now, if you look here, it says this is an example that is going to join data from two different generic lists. We've got a customer class, all right, and we've got an invoice list and a customer list. And this is doing the equivalent of a join. It's allowing us to grab data from both tables. So this would be the query expression. This would be the code that executes that expression, and that would be the results. So we grab from the customer table the customer's name, last name, comma, first name, and from the other table, we grab that customer's invoice amount. And you can see it is possible for one customer to be in there more than once. And if they are, we want the invoice amount to be in descending order, and it is. All right. We're going to get into all this method-based stuff, query expressions, etc. We're going to do all this. And as I said, when I get done with this, I'm going to go in and I'm going to show you how you could very simply go in and I'm going to create a database, and I'm going to actually create a database using two different packages so you can see different ways of doing this. Then we'll go back and we'll do the same program, but we'll do that program as a link program. So again, this is method-based. So the syntax is going to be different, but we can get the same results. Now, Here are some of the link methods that you can utilize. This is not a complete list. All right. Some of these are more designed to be used with numeric fields. Count will give you a count of records. Average is used with a numeric field. Sum is used with a numeric field. Max or min can be used either with a numeric field or with a string type of field. First will give you the first record that meets criteria, null if nothing meets it. First or default will give you the first record that meets that criteria or a default value if none do. Single is assuming that there's only one record that meets your criteria. You can have a single or default, so if nothing meets the criteria, again, you give it a default. All right, skip will allow you to do that with records. Take will allow you to just work with a subset of records. And toList, you got to think about this. What I want to be able to do is run link operations, but I want the results to be shown in a C# program. So sometimes you're going to have to convert your output to a list for it to show. So here's an example. All right, I want you to go through the invoice list, and I want you to give me a count of all of the invoice totals that are greater than 150. So this is going to return a scalar. So if there were 12 that met that criteria, it would return 12. Here's a query that, as it says, gets the invoice total for the items in the results. All right. Here's a query that gets a subset. How do I know that? Because it's skipping some. All right, we've got this customer invoice form that we can create with a query, and it's got each customer's name, their invoice ID, their invoice date, their invoice total. But you'll notice that it's possible that the same customer can be in here more than once. All right. Now they talk in here, and this is not that big a thing, but this says code to adjust column widths so it doesn't go scroll off the screen. All right. Then here's the code for the customer invoice. As it says part 1, there's part 2. Now that's it. So what we're going to do is I am done with this lecture. All right. I am done with this lecture, and it's only 23 minutes. So what I'm going to do when I come back in a few minutes is I'm going to go and I'm going to create a database for you. I'm going to actually create it using 2 different database management systems. And then I'm going to run some queries on it so you can see what the heck is going on. Then we're going to go back and do the same thing, but we will do the same thing as a link program. All right, so I'll be back with that shortly.